Good morning, boys and girls. Welcome back to the eastern wing of the Stinkbug Works. Well, the Miss Seattle has arrived, and it's a tad smaller than I recall. But we are going to do what we're going to do with it regardless. So I took a good look at it, and quite frankly, I don't know why they didn't catch on, and I know exactly why they didn't catch on. And the reason is the same. They drive just like full-size hydroplanes. Well, guess what? Full-size hydroplanes, you got to get them up on step. Otherwise, they just do this submarine thing. If you're gentle with the throttle, it's just going to go underwater, and everybody's going to be, oh, these are no good. They're just submarines, yada, yada, yada. You got to nail them from the get-go and get them up on step. Once they're up on step, they go pretty good. Here's something really interesting I noticed. If you look carefully at the back shape of the sponsons here, let me find a pointer. The back shape here, you see this one has a longer, we'll call it the non-trip. That's probably not correct, but we'll just call it that. Has a longer non-trip than this side. This side, which is the outside in a turn, is a little bit wider than the inside. And if you look at the dead rise, the outside has a bit more dead rise than the inside. Now, that's the exact same geometry I was thinking of putting on a 20-inch hydroplane that I'm working on. Sort of in the back of my mind. It's not getting a whole lot of attention, but I'm doing some planning on it. And this is the kind of geometry I'm looking at, although I'm looking at more of a flatter bottom than this. But this does not have a really big area to trap air, and it actually has an adjustable front canard. Now, it's not highly adjustable, and at the speeds this thing did, I highly doubt it would be helpful, but this could help in the submarining thing. You know, if you're having submarining issues, you do it up like this and hopefully get the bow out of the water. All you got to do is learn how to drive a hydroplane. You nail it. You just nail it, and once it's up on step, you can back off. It has an interesting hatch. It hooks right here at the bottom of the fake windscreen, and there's supposed to be a pin that goes in there. I'll have to get one before it's all said and done. But here is a tape down hatch. Nice touch. Inside, I've already been in here and I tore out the speed control. It's right here. I don't necessarily believe this is the speed control that came with the boat, but it is a 40 amp brushless speed control nonetheless. This thing was actually quite the amazing model. If you look at it, It had a water-cooled motor. The ESC was not water-cooled, so water just came in this side, out that side. And look at this pickup. They picked it up right behind the sponson. That's actually not a bad place to put it. It's not a really great place because you are adding the drag of this thing being in your smooth water slipstream. I had thought about maybe just putting a pipe in through the sponson bottom at an angle and coming out and then just into this hole here. I may still do that. The only thing is then I have to work on the sponson bottoms. I wanted to just leave them alone. I mean, they've got a nice sheet on them. They're square, they're flat. Well, they're not jet perfect flat, but they're flat enough. Inside, it has a little wire drive. This black thing is a seal that goes over the brass stuffing tube. The problem with the wire drive is they're really no longer available. You'd have to wind up making your own. And this one is slightly tweaked. I could untweak it and use it, but I'm not really happy with the sharp bend that the stuffing tube has here. And it looks like the bend should have started here and ended here because it's actually got some positive on the back, which would be forcing the back down. And there's one other thing. Besides the extra low KV on this thing, this is 2200 RPM per volt, and they ran it on 3S. That would give blazingly adequate performance. You might be able to do it for a long time, but they put in this little 800 milliamp, 800 milliamp battery up here. Well, I tell you what, I looked at, I could almost get a 1.8 in here and get the cover to fit, and it would do it. Here, I'll show you. It would do it because of the way the hatch is designed. The hatch is flush with the top of the hull here. So that actually adds some height to the inside. So I could get away with a battery like that, but it's up high. The higher things are, the harder it's going to be to turn. So to that end, I'm thinking about running these airsoft batteries down here. That way it gives me a lot more room for CG adjustment. To accomplish that, I may have to move the servo. The servo is on a plastic glued in thing, and I could just cut that out, and I might just glue the servo down to the deck here. Or I might do the trick where you put some shrink wrap around it and glue it down. We'll have to see. Maybe I could salvage enough of this servo mount that I could move it back a little bit. One of the big beefs about hulls like this, and this one's not so bad because the plastic is really thick. It's kind of heavy. The plastic is really thick, but it still has some flex this way. And you don't want flex that way in your hydroplane. Now, this thing being so light, you may not feel the flex, but I think I'm going to take this carbon fiber rod, cut it to the right length, and put it up against this edge here and run it up to the sponsons, and I'll bevel it, appropriately. And then I'll just put that expanding polyurethane glue right here where it meets the sponson and all along here where it meets the forward edge of the hull and then the sponson again. That really stiffens these things up because the flex is really occurring right along this joint here. So if you strengthen up that joint, that will take a lot of the flex out with very limited additional weight. I think the ubiquitous little 1/8 inch strut that we've seen so many times, I think it has the same mounting holes as this strut, so this may just drop in. The rudder will have to fill and such, and I may want to shorten the rudder to where it's this length. I think I'm about 1/4 of an inch longer than that right now. I've been looking at this motor mount, and I think this motor mount has the motor slightly lower by maybe 1/8 of an inch or so. And every bit lower you can go, the better. So this motor mount is just bolted in from underneath. So the whole motor and mount comes right out. This could just glue right in there. I'm not sure what kind of glue I would want to use on this plastic to glue it to this and this. And you know what? I think I know what might be the ticket. Might be JB Weld. Maybe the marine stuff. Just because this plastic has some flex to it, and none of this flexes at all. So I'm joining flexible to non-flexible. Of course, that's why they bolted it together. I may be better off just going with the bolted. We'll just have to see. I'm going to start taking things apart. I need to replace the stuffing tube because, one, I don't like that it gets higher here and down like that, and two, it's the wrong size. It won't work with, I'm going to run 98 thousandths cable, and 98 thousandths cable won't work with this. Oh, it won't work with my bearing. I could work it with this. I don't like that. That's something we'll just look into. I could use this tubing, this stuffing tube, rebend it through here, use it without a Teflon liner, and then at the end, solder on larger and larger and larger bits of tubing that would fit into the nose cone of this. Or maybe make a nose cone that goes from here to here. We'll just have to see. So that's a possibility I may consider. There you go. I've been talking long enough. Until next time, jet out.